multimeter here is powered on. You can see that light. I don't know whether you can see it. It is on. This cooker socket here, or the cooker unit, is on, but the light here is not turning on. Those are some of the very important questions that you ask your customer. So the MCB is down. Now, once you visit the customer, you have seen that the MCB has tripped. You start troubleshooting. All right, now here is where this important instrument comes in, the multimeter. Digital multimeter. On our yesterday's live stream, we were able to talk much more regarding a digital multimeter. In fact, yesterday we covered much to do with continuity test. We agreed that continuity test is whereby you bring these probes together and then you will hear that beeping sound, and it will shift from a 1 to 0. What does that mean? From infinity to continuity. Is that a little bit challenging for you, my top boss? It means that it is measuring infinity. That is why you have one. Infinity. There is no flow of charges in that medium or media. But again, if you bring them together like that, there is that. You can hear that. I want to thank you so much, my top bosses. I can see constant likes coming from you, my top bosses. It means a lot. It really means that we are together, and you appreciate the work that I'm doing. That's the best that you can do. I appreciate that. Now, if I take a cable here, if I take a cable and then use that to demonstrate continuity, right? How will that turn out? We are also going to talk about sizes of cables and their purpose and why use a specific, because in this live stream we are going to learn a lot. We are not going to, cherry pick. Simply because we have said that we are talking about troubleshooting using a digital multimeter does not mean that we'll stick to that. You can even have as many questions as possible, my top boss, and I'll be reviewing them. So this is a cable. We want to test for continuity. Is it broken? Can it allow the flow of electricity? I say the flow of electricity or the flow of current. Do you hear that sound? My top boss has said, how can I use the multimeter to check the voltage, the earth and neutral in the consumer unit? We are going to that right now. Frank Edward Bahati, what a great name. Good to see you. You're saying I learned much through you, top boss. Thank you so much, Frank. Welcome, welcome, welcome. This is a good question from our top boss, Aminuta. Says, how can I use the multimeter to check the voltage, the earth and neutral in the consumer unit right now? Right now. So this is what we are going to do. We have learned about the continuity test. If you want to learn more about the continuity test, kindly the video that I did yesterday, our previous live stream, you will learn a lot. So we want to test for voltage. When it comes to voltage, my top boss, we are talking about AC. So where do you see this pointer here, or can we say the knob? What can we talk about it? You see this circular knob here. There are so many calibrations here. Should I say calibrations or vices or quantities that we can record with this digital multimeter here? Okay, so this blue that you can see here is the resistance, and record resistance of a wire. Mostly it will find application with even the electronics engineers, those people who are also dealing with instrumentation. Very tough topics right there. I mean courses. We also have current, and this is AC current. You see, when you see A and then that wave, it definitely means alternating current. You're measuring alternating current in terms of amperes. So here is amperes, 200 milliamperes, 20 milliamp, and so on and so forth. At this point here where we have white, we have direct current. You're recording direct current. And first of all, if you want to use a multimeter, you have to know that you will have to isolate that circuit. I hope we know that, because you have to place the digital multimeter in series with that circuit. So let's say you have power or current flowing through a bulb from a battery. So you will simply cut that wire or disconnect it and place your probes in series so that you can record the current. Okay, when it comes to this blue on this part here, this is the capacitance. Also finds a lot of application with our top bosses in electronics instrumentations as well. And you place your capacitors here so that you can record capacitance. You see here, so you'll not be using the probes, all right? So you must be able to know properly the use of a multimeter, otherwise you will blow it up. This point here records what we refer to as a diode, again for our top bosses or our brothers and sisters in electronics engineering. This yellow that you can see here is definitely, first of all, for CX or capacitance, you will have to turn it up to this point. When it comes to the diode, you turn it to that point, all right? Now, when it comes to voltage, direct current voltage, DC, you place it here. So all this white that you can see here, the V, the line and the dots, that is direct current or direct voltage, DC. So you place it here, assuming that we want to take the readings of the voltage of this battery. Is it a battery or is it a cell? Everready is such a great product. So we will simply, in fact, for this one, again, when it comes to taking readings from a digital multimeter, you really need to understand what you are expecting or what you are recording. So for this one, how many volts is this? And is it AC or is it DC? Albert Domenio says it's a cell. Incredible. So my top boss, how many volts are we expecting from this? Albert is very proactive, says dry cell. Absolutely. How many voltage? How many volts do we expect? Is it DC or is it AC? So that we know what to record with our digital multimeter. Juma Yoweri, good to see you. Very proactive here, not just warming our seat here at Top Bosses. Van, you are saying 1.5 volts. Is it AC or DC? What a lame question that is, John. Come on. Come on. But anyway, I just want to know whether we are together. Is it AC or is it DC? 1.5 volts from this one, this battery. DC! Juma Yoeri, you are those students that the teacher used to say, no. You have answered too many questions. Let us hear from someone else. Thank you so much, Juma. Machari Anjeru, what is the answer? DC. Absolutely. Thank you so much, Macharia. I also have Frank Edward Bahati says it is DC. That is incredible. Now, we will place our probe at this point. We have positive terminal here and we have a negative on this other side. This is where I started as a kid. I really understood about these batteries a lot. I mean the cells, because whenever I used to interchange the terminals, I would be faced with a lot of issues. Now, your volt, you see where you place before you record the readings. You see where I've placed it on 2, at 2, because I expect 2.5, I mean 1.5. If I place it at 20, that is too much. That is like taking a reading from a 12 volts battery or a 19.5 volts battery. When it comes to, like, let's say a laptop adapter, it gives a 19.5. I place it on the bottom. Frank Edward Barty says it is DC. It is 1.5 volts DC. Incredible. So that is what we have. 1.486. If we round it off, definitely that is 1.5 volts in DC. What happens if you are recording, taking the reading at AC? What will happen at AC? Do we still get a reading? So I place the probe right there. No, it's good to test, but there are some cases where you are not supposed to risk. It's like risking a multimeter. Recording for at the AC, what do we get? Nothing. I know that is so lame, but just stick with me. So everything on this multimeter here is very intentional. It is not just placed there for the sake of it. So that is what we have. So you must ensure that you understand correctly what you are recording. When it gets to AC, like our top boss had requested to record the readings, we also set it at 750 because we expect a reading of over 240. The closest to that is 200. I will damage my digital multimeter, so I place it at 750. So if I get anything between 200 and 200 and 749 volts, that is okay. My digital multimeter will not be damaged.
Top Boss, in the next video we will be discussing about the live test on a live circuit where we expect AC voltage to be even more than 200 volts. That is from 230 volts AC to 240 volts AC. We will also be identifying faults and fixing them. Top Boss, subscribe to our channel so that you don't miss that episode. See you in the next one.